Hello everyone, hope you all are doing good. I am Anjana from Learnohub, the free learning platform where you can study math, science and SST absolutely free at learnohub.com. In today's class, we are going to discuss ICSE Class 9 Physics Chapter 7 Reflection of Light. We will be discussing about spherical mirrors and their image formation. Are you all ready for the session? Let's begin. Spherical mirrors. We have understood everything about plane mirrors. What are plane mirrors? What are the properties of an image which is formed from a plane mirror? Okay, when an object is in front of a plane mirror, what are the properties of the image is formed? It will be of the same size. The image will be erect. It will be virtual and is formed behind the mirror. Okay, what does virtual mean? The image which cannot be obtained on a screen is called a virtual image. What does erect mean? It will be of the same type. If this is the object, image will be also be like this, upright. Okay. Inverted means upside down. Okay. Upright image. This is what erect means. It will be formed behind the mirror. Okay. So these are the properties of an image that is formed in case of a plane mirror. Now what are spherical mirrors? Before that, what is a sphere? Spherical object. So here I have a bowl in my hand. Yeah. What is the shape of this bowl? It is a sphere. Any other object which is spherical in shape? Yes, we know Earth is a sphere. Then orange is a sphere. Okay, so all these are spherical objects. So first consider a spherical object. Okay, a spherical object. Okay, I am cutting the spherical object. So here we are going to consider a hollow glass sphere. Okay, we have to take a hollow glass sphere. After taking a hollow glass sphere, you will make a cut in this way. Okay. You will be getting two parts. Okay. In one part, one side of it is silvered. Okay. Silvering one part, you will be getting a spherical mirror. Okay. So here, this is a portion that is obtained. Portion of the sphere of the hollow glass sphere. What does hollow glass sphere means? We have two types of sphere. One is solid sphere and the other one is hollow sphere. Inside it will be empty. Nothing will be there. In solid sphere, inside will be filled. Okay. So this is a hollow sphere. So when you cut, you will be getting this type of a portion. In this portion, the back side or the other side, if it is silvered, we will be getting a spherical mirror. So understood what a spherical mirror is? You can make a spherical mirror. Okay. So simple spherical mirror can be made. Take an ice cream ball. You know the ice cream ball, right? So you know in case of an ice cream ball, you don't need to make a cut. You will be having an opening. Okay. So open it. You will be getting the cap. Okay. In this cap, if you take a silver paper and cover the back side, you will be getting a spherical mirror. If you cover the front side, then also you will be getting a spherical mirror. Okay, understood? So this is how you can make a simple spherical mirror. Clear? Types of spherical mirror. There are two types of spherical mirrors. One is concave mirror and the second is convex mirror. To understand, you just need to take a spoon. Okay, when you take a steel spoon and hold it in front of you, you can see your image. Okay, so here when you hold the front side of the spoon, you can see your image. When you hold your back side also, you can see your image. So when you checked it, you will understand that there is a difference. Okay, so when you hold the front side of the spoon, you will be seeing that your image is upside down. Okay, but when you hold it in the way that the back side of the spoon is facing you, you can see that your image is in such a way that you can see it as it is. That is erect image or upright image can be seen. Okay, can you try this? Yes. So take a spoon and try this. Okay. Now here, what are concave and convex mirrors? So we have said a hollow glass sphere is taken. Okay, a hollow glass sphere is taken. It is cut. Okay. So you will be getting a portion like this. Okay. So this is the hollow part. And this is the bulging part, bulging out, bulging part. Okay. Now here in this part, if you silver the back side, that is bulging part if you are silvering. Okay. This part is a glass. So it will be acting as a mirror. This type of a mirror we call the concave mirror. Understood? So this is a concave mirror. So in which case do we get concave mirror, holding it this way or this way? When you hold the spoon with the front side facing you or back side facing you? Front side, right? So when front side is facing you, you can see that this is how it is. Yes, you can see the bulging part is to the back side and the front side you have the hollow part. Okay, so here the reflection will happen when light rays strike this hollow part. Okay, understood. So this is a concave mirror. First type is a concave mirror. A concave mirror is made by silvering the outer surface of the piece of a hollow sphere such that the reflection takes place from the hollow surface. So this is a hollow surface and this is the outer surface, which is a bulging surface. Okay, understood the concave mirror. Next, the convex mirror. That is when you hold the spoon with the back side of the spoon facing you. Okay, you will be getting a convex mirror. So what is a convex mirror? To get a convex mirror, take the same portion. Okay, now silver this part. Okay, this part is silver. Okay, so here the hollow part is silvered and the bulging part is left as it is. Okay, so here reflection will take place when light rays will strike the bulging part. Okay, that is the outside. So here, so this is a convex mirror. Concave mirror and convex mirror. Okay, a convex mirror is made by silvering the inner surface of the piece of a hollow sphere such that the reflection takes place from the outer surface. So here the reflection is from the inner surface and here the reflection is from the outer surface. Okay, so there are two other names for concave mirrors and convex mirrors, which we will be discussing later. Okay, terms related to a spherical mirror. So we have understood what a spherical mirror is and what are the two types of spherical mirrors, concave mirrors and convex mirrors. So we know how to represent a concave mirror and a convex mirror. In case of concave mirror, you will be putting these lines at the back side. Okay, back side. So here convex mirror, this is also at the back side, but here the bulging part is the reflecting surface. Here the hollow part is the reflecting surface. The first term is pole. Okay, what is a pole? So here when you consider a sphere, okay, the sphere will have a center. Okay, this will be the geometric center. Okay, now when you take this part, okay, when you take this part, that is the part which you have cut out. Okay, then it will act as a concave mirror or convex mirror. So here this part will have a center. Yes, this part will have a center. This center we call the pole, which is represented by capital letter P. Geometric center of a spherical mirror is called pole. Next is center of curvature. Center of curvature is this one. That is when you take a spherical mirror, a concave mirror or convex mirror. Okay, we know this will be a part of a sphere. Yes, we know that this spherical mirror is a part of a sphere. This sphere will be having a center. This center is called the center of curvature. Now here in this case of convex mirror, when you complete the circle, okay, when you complete the sphere, you will be getting a center. This center is called the center of curvature, which is represented by letter C. Okay, the center of curvature as the center of a sphere from which the given spherical mirror, convex or concave, is obtained. Okay, it is a part. So we know that the concave mirror and convex mirror is a part of the spherical mirror. Okay, it is a part of the sphere. Okay, the sphere will have a center. The center is called the center of curvature. Next, radius of curvature. What is radius of a circle? What is radius of a sphere? Okay, it is the distance from the center to any point on the sphere. Okay, we know the radius of a circle is the distance from the center to any point on the circle. Okay, similarly, from the center of curvature to any point on the spherical mirror, the distance we call the radius of curvature. So this is R, this is R, this is R. This distance will be same. So this distance we call the radius of curvature, represented by letter R. The distance between the center of curvature and pole. Next is principal axis. So we have to remember one thing, the center of curvature. We know what is a normal. For plane mirror, we know how to draw normal. So what is a normal? So plane mirror normally we have represented by this is a plane mirror, M dash. Okay. So here you will be having incident ray. So there will be a normal. So this is your incident ray. This is reflected ray. This is point of incidence. Okay. Normal is a line which is perpendicular to the mirror and it touches or it passes through the point of incidence. We know this. Okay. Now when you take the normal, okay, when you take the normal, this normal will be passing through a point on the mirror and the center of curvature. Okay. So when you draw a normal, that normal will be passing through the center of curvature and the point on a sphere. Okay. So next is the principal axis. To get the principal axis, we have understood what pole is. We have understood what the center of curvature is. Okay. So when you draw a straight line, if it passes through the pole and center of curvature, this line we call the principal axis. Okay, principal axis, a straight line joining the pole and the center of curvature. It's not just joining, it is a line that is passing through the pole and the center of curvature C. Next is aperture. The plane surface area of the mirror through which light rays enter and fall on the mirror is called its aperture. So here you can see this is the plane surface. Okay, light rays will be striking this plane surface. Okay, after striking, what happens? Reflection happens. It gets reflected. So striking and falling of the light rays will happen on this plane surface. This plane surface we call the aperture of the spherical mirror. So understood these terms? These are very important terms which we will be using throughout this. Okay, pole, center of curvature, radius of curvature, principal axis and aperture. Okay, reflection of light ray from a spherical mirror. So reflection of light ray from a spherical mirror obeys the laws of reflection. You remember the laws of reflection? We have discussed the laws of reflection in case of a plane mirror. What are the laws of reflection? First law of reflection is angle of incidence is always equal to the angle of reflection. Incident ray, reflected ray and normal at the point of incident all lie on the same plane. Okay. Incident ray, reflected ray, normal at the point of incident all lie on the same plane. So these are the two laws of reflection. So the case of plane mirror, we know the light ray which strikes a plane mirror. Okay, what happens? It gets reflected. The angle, when you check, the angle made between the incident ray and normal, which is the incidence angle, will be equal to the angle made between the normal and the reflected ray, which is the angle of reflection. So we have studied. Now we will take the case of the spherical mirrors. Okay, first we'll consider the case of a concave mirror. So here we have a concave mirror. This is your principal axis. Here we have pole and here we have center of curvature. Okay, now consider a light ray. So AD is my light ray, incident ray. Okay. So once the incident ray strikes the concave mirror, what happens? It should get reflected. Okay, it should obey these two laws. So reflection, the laws of reflection should be obeyed. Only then the reflection will happen. So to get that, what you have to do is, a line is drawn from D passing through C, which is the normal. Okay, C is the center of curvature and point of incidence you have to join and draw a line. So we got the normal. Okay, now we can measure the angle. This angle can be measured, which is the angle of incidence. So, ADC is the angle of incidence. Okay. Now, how can you draw the reflected ray? We know that the angle of incidence and angle of reflection will be the same. Now, from the normal, you will have to measure an angle which is equal to I, which is equal to ADC. So, measure the angle. So, when you measure, you will be getting this much. Okay, which is equal to I. So we got R, angle of reflection. So we have drawn a ray. It will strike this point. Okay, so this is your reflected ray. Here incident ray is AD, reflected ray is DB, normal is CD, angle of incidence is ADC and the angle of reflection is angle BDC. We know that angle ADC will be equal to angle BDC. Okay. Now check the second law. Okay, you can see that incident ray, reflected ray, normal at the point of incident. All of them I can represent on this board, which means they lie on the same plane. Clear? Now let us take the case of a convex mirror. How do you represent a convex mirror? So this is a convex mirror. You have the principal axis. This is the pole. Okay. Here the center of curvature will be here. Okay. That is behind the mirror you have the center of curvature. Now consider the light ray, incident light ray. AD is your incident light ray. Okay. To draw the normal, a straight line that is passing to the point of incidence and center of curvature is drawn. I am extending it further. Okay. Next, what you have to do? You have to measure the angle that is made between the incident ray and the normal. This part, not this part. This part you have to consider. Okay. That is in front of the mirror. For that purpose, we are extending the normal. Okay. Measure this angle. You will get the angle of incidence. Okay. Angle of incidence. So, here, this is your angle of incidence. So, let me put a C dash here. So, angle ADC dash is the angle of incidence. Now, to get the angle of reflection, what should be done? From here, from normal, we have to measure an angle that is equal to I. Angle ADC dash. Okay. So, when you measure, you will be getting the reflected ray. This is your reflected ray. Okay. Reflected ray. This is the angle R. So, here R is equal to angle BDC dash. Okay, and angle ADC dash is equal to angle BDC dash. So, here again you can check, is a reflected ray, incident ray, normal at the point of incidence, all of them lie on the same plane. So, got it? This is how reflection happens in case of a spherical mirror. That is, separately we have discussed in case of a concave mirror and a convex mirror. So, we have seen that the angle of incident and angle of reflection are same. Focus and focal length. So, we have understood what is principal axis, what is pole, center of curvature, normal, aperture, etc. Okay, now what is focus of a spherical mirror? What is focus of a concave and convex mirror? So, here you can see that we have taken a concave mirror. Okay, these are the incident light rays. Okay, light rays from a source. Incident light rays after reflection, what is happening? You can see that all the incident light rays, you can see the first light ray is striking at this point, second light ray is striking at this point, third light ray is striking at this point, fourth light ray striking here, fifth light ray is striking here. So, what is happening after reflection? After reflection, so here you are considering an infinite source. Okay, light rays are from an infinite source. After reflection, what is happening? These are the reflected light rays. Okay, after reflection, what is happening? They are converging at a point. Okay, they are converging at a point. This point we call the principal focus of a concave mirror. Okay, so from this we have another name for a concave mirror, which is converging mirror. Converging mirror. Okay, concave mirror is also called converging mirror. Light rays after reflection converge at a point on the principal axis. This point is called the principal focus of a concave mirror, which is represented by capital letter F. Okay, next is the convex mirror. Okay, so this is a convex mirror. Here again you can see the incident light rays. This is the first light ray, second light ray, third, fourth, fifth. Here what is happening after reflection? You know how the reflection will happen? Yes, after reflection what is happening? We have drawn the normal and all. After reflection you can see that they are not converging at a point. They are moving in different direction. Yes, they are moving in different direction. They are getting spread. Okay. So here you can see that the light rays are getting spread, but all of them are emerging from one point. Okay, they are starting to diverge from one point. This point is called the principal focus of a convex mirror. Okay, light rays, principal focus of a convex mirror. To explain, we can say that light rays after reflection, parallel light rays after reflection from a convex mirror appear to diverge from a point on the principal axis. This point is called the principal focus of a convex mirror. Okay, so for a concave mirror, the focus of a concave mirror is a point on the principal axis through which the light rays incident parallel to the principal axis pass after reflection from the mirror. So here we have considered a source which is at infinite distance. Okay. Then the case of a convex mirror, the focus of a convex mirror is a point on the principal axis from which the light rays incident parallel to the principal axis appear to come after reflection from the mirror. Okay, so this type of mirror, convex mirror, is therefore known as diverging mirror. So one is converging mirror and the other is diverging mirror. Okay, understood. So we have understood what is focus of a concave mirror and a convex mirror. So the distance between the focus and the pole is called the focal length. Focal length is represented by small letter f. Okay. Focal length is the distance of the focus from the pole of the mirror. Next is focal plane. What is focal plane? A plane passing through the focus and normal to the principal axis of the mirror. Okay. So here we'll be having a plane which is passing through the focus. Okay. So here you can see incident light rays. Okay. So in each case we can draw the normal. First case, a normal is a line that is passing through the point of incidence and the center of curvature. Only then you will be getting the normal. So here we have the first normal. Okay. Now for the second light ray, we can draw the normal. This is the second normal. Here we can draw the third normal. Here we can draw the fourth normal. Here we can draw the fifth normal. Okay. So you can see that there is a plane which contains the focus. Okay. It contains a focus and also it contains the normal to the principal axis. Okay. Normals are drawn to the principal axis. Okay. So points of these normals are also along the same line. Okay. So this plane we call the plane containing the focus and the normals to the principal axis we call the focal plane. Okay. So this is a focal plane. So here similarly, you can draw the focal plane in case of a convex mirror. Here we have the focus, normals can be drawn, a plane will be obtained. Okay, this plane is called the focal plane. Convenient rays for the construction of image by ray diagram. So we know we have studied the ray diagrams in case of a plane mirror. Okay, so here we'll be considering, we know that there are infinite number of light rays, but we'll be considering only few light rays. 4 different light rays will be considered, which helps us in finding the image that is formed. The nature of image, the size of image can be studied only when these 4 light rays are considered. The first one is a ray passing through the center of curvature. So here you can see a concave mirror, convex mirror. Okay. Now this is the concave mirror. Here we have the principal axis, pole, focus, center of curvature. Okay. Now we have also said that a line that is passing through the center of curvature and the point of incidence is what the normal is. Okay. So here you can see a light ray that is passing through the center of curvature. This is the incident light ray. Incident light ray, what is happening after reflection? It is striking at a point on the mirror. Okay. What is happening? Reflection is happening. So this is the reflected ray. Reflected ray is also passing through the center of curvature. Why this is happening? So here the normal and the incident ray are coinciding, which means the angle of incidence in this case is equal to 0, because the angle of incidence is the angle between the incident ray and the normal. Here in this case, the angle of incidence is 0. What about the angle of reflection? There is 0. Angle of reflection is also 0. Why? Because the reflected ray is also coinciding with the normal and the incident ray. Okay, the angle made between the normal and the reflected ray will also be equal to 0. Yes, so this is the case of a concave mirror, a light ray that is passing through the center of curvature. After reflection, the reflected ray will also pass through the center of curvature. Okay, this is a case of a concave mirror. Now, when you take the case of a convex mirror, okay, here in case of a convex mirror, a light ray which is subjected towards the center of curvature. Why? Because the center of curvature of a convex mirror is behind the mirror. Okay, it is behind the silvered part. It is not in front of the mirror. Okay, in this case, a light ray which is subjected towards the center of curvature after reflection will appear to come from the center of curvature. Okay, so here you can see this is the incident light ray, this is the normal because it is a line that is passing through the center of curvature and touching the mirror. Okay, this is your reflected ray, it is coinciding with the incident ray and the normal. Here again the angle of incidence is equal to 0, angle of reflection is also equal to 0. Okay, a ray passing through or directed towards the center of curvature of a spherical mirror is reflected back along its own path. Incident ray and the reflected ray will be coincide. Second ray is a ray parallel to the principal axis. So here you can see this is a concave mirror. Okay, AB is a light ray which is parallel to the principal axis. Okay, this is the incident light ray. B is the point of incidence. After reflection, you can see that the light ray is passing through the focus. The reflected ray is passing through the principal focus of a concave mirror. Now, in the case of a convex mirror, you can see that AB is the incident light ray. What is happening after reflection? After reflection, we can see that the reflected ray appears to come from the principal focus. If there are many number of light rays, that is from an infinite source, if you have parallel light rays, you can see all of them converge at the principal focus. In case of a concave mirror, there are infinite number of light rays. All of them appears to diverge from the principal focus of a convex mirror. Okay. So, a ray incident parallel to the principal axis after reflection from a spherical mirror either passes or appears to be coming from focus. So, here it passes through the focus in concave mirror and appears to come from the focus in the case of a convex mirror. Okay. Now, the third one is a ray passing through the focus. So, last case we have discussed a ray which is parallel to the focus. After reflection, what is happening? It will converge to the focus or appear to come from the focus. Here, it is just the opposite. A ray which is passing through the focus, after reflection, it will be parallel to the principal axis. Take the case of a concave mirror. So, here you can see this is the incident light ray which is passing through the focus. Okay. This is a point of incidence. After reflection, you can see the reflected ray and this reflected ray is parallel to the principal axis. Yes. Now, the case of a convex mirror. Here, in case of a convex mirror, the light ray is directed towards the focus. Okay. It is directed towards the focus. So, this is the incident light ray. It is striking the convex mirror. After reflection, what is happening? After reflection, the light ray is moving, that is the reflected ray is moving parallel to the principal axis. Okay, so this is a third case. A ray either incident from the focus or converging at the focus after reflection from the spherical mirror becomes parallel to the principal axis. Now the fourth one, the ray incident at the pole. Okay, so here you can see in case of a concave mirror, this is the incident light ray. Point of incidence is at the pole. So what is happening after reflection? After reflection, you can see this is the reflected. Let's say AP is the incident ray. Okay. And PB is the reflected ray. So here you can see an angle is formed, angle of incidence. Angle of incidence I is equal to angle APC. Angle of reflection R is equal to angle BPC. They will be equal. The angle formed between the normal and the incident ray is the angle of incidence, and the angle formed between the normal and the reflected ray is the angle of reflection. So here you can see that if this is the incident ray, just the opposite direction, you will be having the reflected ray. Same as in the case of a plane mirror, we had the same thing. Okay, if the light ray is incident towards the pole, this is what happens. Okay, now in the case of a convex mirror, again the same thing. Here you can see the incident ray is towards the pole. It is striking the point of incidence is pole. Let's call this A dash P is the incident ray. Okay, and here we have C dash. B dash P is the reflected ray. Okay, this is the reflected ray. Angle of incidence I is equal to A dash P C dash. Here C dash is taken. Why? Because C is the center of curvature which is behind the mirror. Okay, so we are just consider C dash point. Okay, to get the angle. Next, angle of reflection is equal to B dash P C dash. And these two angles will be equal. A dash P C dash is equal to angle B dash P C dash. Okay, so this is a case of light ray which is incident towards a pole. Okay, the ray incident at the pole. For a ray incident at the pole of a spherical mirror, the reflected ray is at an angle of reflection equal to the angle of incidence with the principal axis as normal. So here the principal axis will be the normal. Why? Because what is principal axis? We know what is normal. Yes, what is normal? A normal should pass through the point of incidence and the center of curvature. So when you draw a line in this case, here the point of incidence is P. The point of incidence is pole and C is the center of curvature. When you draw a line, this is the line and the same line is the principal axis. Because we know principal axis is a line which passes through the center of curvature, focus and the pole. Okay. Now we will draw ray diagrams for formation of images in case of a concave mirror. So 6 cases we will be discussing for concave mirror and 2 cases in the case of convex mirror. So first case is when object is at infinity. This we have already discussed. When the object is at infinity, there are many number of parallel light rays, okay, from the source. Okay, so this is an infinite source which an object AB is at infinity. Okay, you can see the light rays are falling on the concave mirror. What is happening after reflection? After reflection, so these are the incident light rays. After reflection, they will converge at the focus. Incident light rays, they will converge at the focus. There will be infinite number of light rays. Okay, all of them will converge at the focus. Okay, so image will be formed at the focus. Okay, so where is the image formed? If the object is at infinity, image will be formed at the principal focus of a concave mirror. So first thing we got where image is formed. Okay, where the image is formed at the focus. Now next thing we have to study the nature of the image. Okay, so infinite source mean, for example, sun is an infinite source, so it is a massive object. Okay, now when you take the image of it, you can see it will be very small. So for example, you can do this, you take a concave mirror. Okay, hold it in such a way that sunlight falls on it. Okay, and place a paper in front of the mirror. Okay, that is a paper should be between the sun and the concave mirror. Okay, the light rays which are falling on the light rays from sun which are falling on the concave mirror after reflection should be on the paper. Okay, you can see that the paper will start burning because here what happens is all the light rays will get focused at a small point. Okay, at a single point on the paper. So this paper can be considered as a screen. So we know that an image that can be obtained on a screen we call a real image. An image that cannot be obtained on a screen is called a virtual image. So here in this case, we know in case of plane mirror, always we get a virtual image. But in this case, we are getting, in case of a concave mirror, when the object is at infinity, we will be getting an image which is a real image. Okay. So here we can say when the object is at infinity, the image is at the focus, principal focus F. Okay. First property is that the image formed is a real image. Real image. Okay, we know that the real image will always be an inverted image. So to remember this, virtual images are always upright or erect. For example, you can imagine the case when you stand in front of a plane mirror. In case of a plane mirror, we are getting a virtual image and we all know that that is an erect image. Yes. So always remember virtual images are erect and real images are inverted. So the second one is the image formed is an inverted image. Okay, second nature, it is an inverted image. Okay, now about the size. So we have said that sun is a massive object. Its image is being focused at a small point, very small point. Okay, which means the sun's image is reduced to a very small size. That means we can say that the image is highly diminished. It is not just the size has reduced, but it has been highly reduced. Okay, highly diminished image is formed. Highly diminished. Now, where is the image formed? We can see that the object is in front of the mirror. Yes, what about the image? Image is also in front of mirror. So we can say that the light rays, okay. So when an object is at infinity, image is formed at the focus. What are the properties of the image formed? The image formed is a real image. It is an inverted image if the object is in this way. So here our object is AB. The image will be very small and the image can be represented as A dash, B dash. So head part becomes the tail part in case of image and the tail part will become the head part in case of the image. Okay. Next property, it is an inverted image, and next is highly diminished image is formed. Where the image is formed? Image is formed in front of the mirror. That is, object and image are on the same side. Understood? When object is at a far distance means when you consider the rays which are from the same point will be parallel rays, but from different point you will be getting inclined rays. Okay. So here you can take this case, you can see AB. Okay. AP is the first. We are considering a tree. Okay. From one point of the tree, we are considering 2 light rays. Okay. So AP is the first incident light ray. It is incident at the pole of the mirror. Okay. And BD is the second light ray. It is incident at D. You can draw normal. How is normal drawn? From the point of incidence, draw a line that is passing through the center of curvature. So here, in first, when you take the case of first incident light ray, AP is the first incident light ray from P. The line passing through P and center of curvature will be its normal. Okay, so this is a normal. So angle of incidence in the first case, the angle of incidence is equal to angle APF. APF is the angle. This one. Okay. Next light ray, BD. Okay, BD is the incident light ray, point of incidence. Line passing to the point of incidence and center of curvature is a normal. So normal is drawn. Here the angle of incidence. This is the angle of incidence. So second case, the angle of incidence is angle BDC. BDC is the angle of incidence. Okay. Now what about the reflected ray? Reflected ray will make the same angle. We know this. Okay. So here in the first case, you can see the reflected ray is PA dash. Okay. PA dash is the reflected ray. It is making an angle that is equal to the angle APC or APF. Both are the same. Okay. So this is the first reflected light ray. Second reflected light ray will make this angle. Okay. Angle of reflection will be equal to A1DC. Okay, here it is R is equal to angle A1PF or A1PC, and here the angle of reflection is angle A1DC. Okay, now you can see the reflected light rays are striking at a point. Yes, these are parallel rays, but after reflection, what is happening to these rays? They are striking at a point. Okay, this point is marked. Okay, and the image will be formed. So here you have the focus. Okay, so from the focus, you have the image. Okay, so this is the image of the object formed. Let's say this is A1B1 or A1F. Okay, this is how the image is formed. Here, what are the properties? Now here you can say that image is formed. Where is the image formed? Image is formed at the focus. Properties of the image, same focal plane of the mirror. Image is also in the focal plane. Okay, image is in focal plane. Okay, next properties of the image. What has happened to the image? The image formed is a real image. It can be obtained on a screen. Real image. Okay, you can take this case, that is, consider a tree which is far. Take a concave mirror, try to focus it. Okay, and keep a screen. You can obtain the image. Next, real images are always inverted, upside down. Okay, what else? The image is highly diminished. Very small image is formed. Highly diminished. Now, where is the image formed? Image is formed in the same side. Yes. So, object is in the left side of the mirror and image is also on the left side of the mirror. Which means the image is formed in front of the mirror. Object and image are on the same side. Okay, now the third case, when object is beyond C. Beyond C means just behind C. Okay, here you can see the object. Object is AB. AB is behind C. Okay, first you will be considering different light rays. First light ray that you consider is a parallel light ray. Okay, this is your first light ray. You can see the parallel light ray. What is happening at this M is the point of incidence. After reflection, we know a parallel light ray will pass through the focus. Okay, so this is the reflected ray. Parallel light rays, reflected ray you can see. So first light ray that we consider is this one. It is passing through the focus. Okay. Now, the second light ray that we are considering is the light ray which passes through the center of curvature. Okay, from the head of the object, you are considering a light ray that is passing through the center of curvature. We know that a light ray which is passing through the center of curvature, after reflection, it will follow the same path. So, this is the incident ray, this is the reflected ray. Okay, only these two are enough. If these two are there, you can find the image. So, image is formed. Now, consider the reflected ray. So, this is the first reflected ray and this is the second reflected ray. So, they are coinciding at a point. Okay. In this case, a third ray is also considered. So, this is your third ray, which is towards the pole. Towards the pole, what happens? The reflected ray will start from the pole. It will be making an angle. Okay, the angle will be the same. So, these are the three rays. You can see that all of these three rays are meeting at a point. Okay, so mark this point. Okay, mark this point. Okay, now from the principal axis, draw a perpendicular to this point. Okay, so this is a perpendicular. So, here we have obtained the image. So, this is the image A dash B dash. Okay. Now, what are the properties? Where is the image formed? First thing. So, here you can see when the object is beyond C, the image is formed between the focus and center of curvature. Here we have the focus. Here we have the center of curvature. So, image is between the focus and center of curvature. Now, what are the properties of the image formed? First property, you can see what type of image, real or virtual. It is a real image because it can be obtained on a screen. Yes. So, the real image is formed. Real image. Real images are always inverted images. Inverted images you can see. So, here the object is AB and the image is A dash B dash. Object was in this way, the image is in this way. Okay. Now, the third property, what about the size? You can see that the size has reduced. Okay, size. This is AB and the size of A dash B dash has reduced. Okay, it has not become a point. So that we can say it is not highly diminished, but still it is diminished. Diminished image is formed. Where is the image formed? Image is formed on the same side as the object is. Okay, that is, here you can see left side of the mirror we have the object and the image. Okay, image is formed in front of the mirror. When a screen is placed, you can obtain the image. So this is your third case. Now the fourth case, that is we are moving from infinity to pole. Okay, so first case, so here when you have a line, this is pole, here we have focus, here we have center of curvature, then here it is infinity. So our first case was at infinity. Okay, from infinity, next case we have took a far away distance. Okay. After that, beyond C, the object was beyond C. Next case is, here we are considering object at C. After C will be, the object will be between C and F, then at F, then F and P. Okay, so we are moving forward. So what is happening to the image? So from these we have understood that when the object is moving forward, image is moving backward. Okay, when the object is moving towards the pole, what is happening to the image? Image is moving backward. Okay, now we'll take this case. So in the first two cases, we had the image at the focus. Third case, the image was between the focus and center of curvature. Now let's see this case. Okay, here the object is at the center of curvature. Okay, object at the center of curvature. This is the object AB. First light ray which is parallel to the principal axis. AD is the light ray, D is the point of incidence. After reflection, the light ray is passing through the principal focus. Second light ray we are considering this light ray which is passing through the focus. So here in this case, the two convenient light rays are one that is parallel to principal axis, the second one that is passing through the focus. Okay. A light ray which is passing through the focus. Here we have the point of incidence. What happens after reflection? It passes parallel to the reflected ray passes parallel to the principal axis. So we have obtained two light rays. Okay. So first light ray, incident light ray, this is a reflected ray. Okay. Second incident light ray. Here we have the incident light ray and this is the reflected ray. So what is happening? They are coinciding at a point. Okay, they are intersecting at a point. This point of intersection is considered. Now draw a perpendicular line from the principal axis. Okay, so from this point to the principal axis, you are drawing a perpendicular, you will get the object. You will get the image. So AB is the object. Image is A dash, B dash. So where is the image formed in this case? You can see AB is at C and A dash, B dash is also at C. Okay. So when an object is at the center of curvature, image is also formed at the center of curvature. Now what are the properties of the image? Is it a real image or virtual image? The image formed, you can see it is a real image. It can be obtained on the screen. Okay. So image is a real image. Next, inverted or erect. Here AB has changed to B dash, A dash, which means real image we know are always inverted. What about the size? You can see that the size is the same. Okay. So when the object is, this is the only case when you place an object at the center of curvature, you will get an image which is at the center of curvature and it will be of the same size as that of the object. So same size. So here we have understood that when the object is moving towards the pole, image is moving away from the pole. Okay. When the size of the object, okay, we are considering object is of the same size. What is happening to the image? First case, image was point sized. Second case also it was a very small image, highly diminished image. Then third case, it was a diminished image. Now what happened? The image is of the same size as that of the object. That is, the size of the image is changing. Size of image is increasing. Yes. So these are the properties. Here again, the image is formed on the same side as that of the object. Yes. Image is formed on the front side. It can be obtained on a screen. Now the fifth case, when object is between C and F. So we have completed C. Now the object is between C and F. So here you can see AB is the object. First light ray which is parallel to the principal axis. After reflection, you can see it is passing through the principal focus. Okay. Second light ray which is passing through the principal focus. After reflection, it is moving parallel to the principal axis. Okay. So these light rays, you can see the reflected rays will intersect at a point. So this is a point of intersection. Mark it as A dash. From there, draw a perpendicular to the principal axis. A perpendicular is drawn. Mark the point. Mark it as B dash. Okay. So we have obtained the image. AB is the object. Image is B dash, A dash. So here you can see when the object is between center of curvature and focus, the image is formed beyond C, behind C. Okay. What are the properties of the image? Is it a real or virtual image? It is a real image. It can be obtained on a screen. Surely it is an inverted image. Real images are inverted. Inverted image is formed. What else? What about the size? Here you can see object is smaller than the image, which means what has happened to the size? The size has increased, which means enlarged. Enlarged. Okay. And the image is formed on the same side as that of the object. Okay. Image is formed in front of the mirror. A screen can be kept and the image can be obtained. Now the sixth case, when the object is at focus. So, previous case we have discussed when the object is between center of curvature and focus. Here the object is at focus. You can see AB is the object which is at focus. First light ray which is parallel to the principal axis. After reflection it is passing through the focus. Okay. Now the second light ray which is directed towards the center of curvature. You can see this is the light ray directed towards the center of curvature. So, here this is the light ray. Okay, after striking the mirror, it is directed towards the center of curvature. Okay, a light ray that is appearing to come from the center of curvature after reflection is directed towards the center of curvature. So, what happens? So, here you can see that these are parallel rays. Okay, these are parallel rays. So, we have discussed the first case from infinity when light rays. Okay, when parallel light rays comes, what happens? All of them gets focused at the principal focus and the image is formed over there. Here the object is at focus. Okay, and the image in that case will be formed at infinity. Image will be formed at infinity. That is just the opposite case. In the first case we have discussed, the object was at infinity, image is at focus. Here the object is at focus, therefore image will be at infinity. Okay. After second case, it can do a similar case. Third case, we have discussed object was beyond C. Image is formed. Where is the image formed? Image is formed between the center of curvature and the principal focus. Yes. What about the fifth case? In the fifth case, we have seen the object is between the center of curvature and the principal focus. The image is formed beyond C. Just the opposite. Similar here also, the opposite cases happen. Okay. So, when the object is at F, the image is at infinity. Parallel light rays means the image will be formed at infinity. Okay. Now, what are the properties of the image? Here again, the image formed will be a real image. Okay. It will be an inverted image. What about the size? The size will be highly enlarged. Highly enlarged. So, these are the properties of the image. The image will be formed on the same side as that of the object. Okay. So, got the sixth case. So, this is your sixth case. Now, the final case with concave mirror, case 7. Okay, of this the first, third, fourth, fifth, sixth and seventh are very important. Second case is almost similar to the first case. Okay, we have just considered that a far away object, not that the object is at infinity. Infinity means you are considering the sun. Okay, far away object means you are considering any tree which is at a very large distance. So, when object is between F and P. In this case, you will be getting the properties of image as a different one. That is, in the final case, you will be getting the image properties to be very different. Okay. So, here you can see AB is the object. First light ray which is parallel to the principal axis. It is incident at D and you can see the reflected ray. Okay. This is your reflected ray. Okay, which is passing through the principal focus. Second light ray which is from the center of curvature. So, here it is appearing to come from the center of curvature. We are considering the second light ray which is appearing to come from the center of curvature. Reflected ray will also be towards the center of curvature. Okay, so here you can see these rays when you extend, the reflected rays when you extend, they are not going to meet. Okay, we know that when the light rays are in this way, okay, if the reflected rays are in this way, when you extend, you can see that they will meet at a point. But here in this case, you can see the rays are in such a way that one is in this way and the other is in this way. Okay. So, if you still extend, what is happening? Never they are going to meet. So, in the other direction, you are going to extend now. Okay. So, if you extend in here, what happens? They will meet. But here you can see the extending can be done only behind the mirror. Okay. When you extend, they will be meeting. They will be intersecting at a point, but that point will be behind the mirror. So, if this is happening, it means that the image is formed behind the mirror and the properties of images are also going to change. So, first light ray I am extending. Second light ray also I am going to extend. They are meeting at a point which is A dash. Okay. Draw a perpendicular from A dash to the principal axis. We get a point which is B dash. Image is formed. Now we can study the properties of image. Where is the image formed? First question. Where is the image formed? Here in this case, the image is formed behind the mirror. Okay. Image is formed behind the mirror. Now the properties of image. Here the image is formed as a virtual image. Virtual image is formed, which means you cannot obtain this image on a screen. Like this is a case when an image is formed in the case of a plane mirror. We know that when you stand in front of a plane mirror, you cannot get your image. Okay, you cannot obtain it on a screen. Similar is this case. Okay, now the second is, we know always the virtual images are upright or erect images. Erect or upright. Okay, so here you can see this is the object AB. And image A dash, B dash. Okay, so how the image is? Head and tail, head and tail. Okay, same. So this is an upright image or an erect image. Next, what about the size of the image? So what has happened to the size? We are getting an enlarged image. Yes. So therefore, it is an enlarged image. Virtual image cannot be obtained on a screen. Image formed is an erect image and it is an enlarged image. Only in this case, that is a final case, when the object is between the focus and the pole, the image formed will be behind the mirror and the properties will be entirely different. In all other cases, the image is formed in front of the mirror and the properties will be the same. Only this difference will come to this final one, that is diminished. First it will start with highly diminished, then it becomes diminished, then it becomes same size, enlarged, highly enlarged. Okay, now with this table we can make a comparison with the properties of the image that is formed. First we'll start with the first position. So here we have not included the second case. In second case is similar to the first case itself. Okay, all the properties will be the same. At infinity, beyond C, that is the object is moving towards the mirror. What happens to image? I have said the image will be moving away from the mirror. They don't consider the final case. In final case, it is not it is moving away from the mirror. It is formed behind the mirror. In all other cases, you can see. So first one, object is at infinity, image is at the focus, F. Okay. When the object is at focus, image is at infinity. Okay. Next, when the object is beyond C, that is the second case, image is formed between C and F. Okay, when the object is between C and F, just the opposite. Okay, image is beyond C. At C, at C. Now, what about the properties of image? You can just compare and study. Okay, first case, when object is at infinity, what is the property of the image form? It is highly diminished. It is a point-sized image. Okay, just the opposite case, that is object at infinity and image is formed. Object is at focus and image is formed at infinity. In that case, here if it is highly diminished, here it will be highly enlarged. Okay, next, beyond C, that is the second case. Here you can see a diminished image, which means the reverse, that is the opposite case. Between C and F, it will be a enlarged image. At C, we are getting the image which is of same size. So when the image is moving away from the mirror, what is happening? The size is increasing. Started from highly diminished point size, it became diminished, then same size, enlarged, highly enlarged. Okay, then what about the nature of the image? In all these 5 cases, we are getting real and inverted image. Okay, real and inverted. The final case is very different. Yes, here the object is between the pole and focus. In that case, only in this case, the image is formed behind the mirror. Properties of the image, enlarged image is formed. Okay, only in this case, you will be getting a virtual and erect image. So, you may get question, where should an object be placed to obtain a virtual and erect image in case of a concave mirror? Where it should be kept? It should be kept between a pole and the focus of the concave mirror. Ray diagrams for the formation of images in a convex mirror. So, in case of concave mirror, we have discussed 7 cases. Here, we don't have 7 cases, just 2 cases we have to study. The first case, when object is at infinity. So, this is a case, light rays. Okay, here you can see the parallel light rays. AB is the object which is at infinity. So, first light ray which is starting from A. Okay, it is striking at this point on the convex mirror. Okay, light ray from B is striking at this point on the convex mirror. So what is happening in case of convex mirror? What happens? A light ray which is parallel to the principal axis of a convex mirror after reflection appears to diverge from a point on the principal axis. This point is called the principal focus. Yes, we know this. Okay. So here it appears to come from a point on the principal axis which is the principal focus. So this is the light ray. Okay. First light ray. Then here it appears to come from a point on the principal axis. So this is one. So when you extended these rays, these reflected rays, when extended, they will meet at a point and here the image is obtained. Okay. Image will be formed over here. Now let us discuss the properties of the image. Okay. Here first one, where is the image formed? Where is the image formed? Image is formed behind the mirror at the focus. At the focus. Okay, so when the object is at infinity, the image is formed at the focus. We know that in the case of a convex mirror, the focus and center of curvature will be behind the mirror. Okay, now properties of the image. First, is the image real or virtual? In this case, it is formed behind the mirror. Behind the mirror means a virtual image is formed. We know virtual images are always upright or erect. Erect image will be formed. Here the size, what happens to the size of the image? When object is at infinity, in case of concave or in case of convex, whatever it is, the image will be formed at the focus. The only difference is that in the case of a concave mirror, you are getting a highly diminished point image, but it is a real and inverted image. Here it will be a virtual and erect image. The size will be highly diminished. Highly diminished or point sized. So where is the image formed? Is it on the same side as that of the object? No. Here the image is formed behind the mirror. So these are the properties of the mirror. First case you understood. Now the second case, when object is at any point in front of a convex mirror. Any point it can be. Okay. It is just that the object is in front of a convex mirror. Okay. First light ray. First light ray which is parallel to the principal axis. This is the light ray. A light ray which is parallel to the principal axis after reflection appears to diverge from a point on the principal axis. So here it comes from the point focus. So this is the reflected ray. Okay. Second light ray which is towards, we are considering the second light ray which is towards the center of curvature. Towards the center of curvature. After reflection, what happens? A light ray which is towards the center of curvature, it will follow, the reflected ray will follow the same path of incident ray. Okay, so this is the reflected ray. Yes, we got the reflected ray. So here we are extending the first reflected ray. You can see these lines will coincide at a point. Okay, here we draw a perpendicular to the principal axis. We have obtained the image. So A, B is the object and A dash, B dash is the image. Okay. Where is the image formed? Image is formed behind the mirror. Okay. So when the object is at any point in front of a convex mirror, the image is formed between focus and the pole. Behind the mirror, you can see here we have the pole, here we have the focus. Between the pole and focus, image is formed. Okay. Next, what are the properties of the image? You can see that the image, this is object AB, this is image A dash B dash. So it is a upright image or it is an erect image. Erect images are always virtual. So first property, it is a virtual image. It is an upright or erect image. Third, what about the size? Here again we are getting a diminished, not highly diminished, but still it is a diminished image. It is formed on the back side of the mirror. Okay. So when you take the case of a convex mirror, in both the cases, okay, first case that is object at infinity or object at any point in front of the mirror, we will be getting an image which is, that is the size of the image will be reduced. Virtual and erect image, always it is virtual and erect. So a mirror which doesn't form real images. Okay, when you take two spherical mirrors, concave and convex, which among this does not form a real image is a convex mirror. It always forms virtual and upright or erect images. Clear? Okay, so that is why we have checked when you take the spoon, Okay, hold it in front of you. Okay, back side you are holding in front of you, the mirror, it will act as a convex mirror. So you can see an upright image. Yes, upright image is obtained. Now let us conclude. Position of the object at infinity. This is a case of a convex mirror at infinity and between infinity and the pole of the mirror. Where is the image formed? At the focus behind the mirror, and here between focus and the pole, again behind the mirror. Size of the image, highly diminished point sized. Here it is diminished. Anyways, a small image. Comparing to the object, a smaller image is obtained. Next, property virtual and erect. Nature of the image, it is always virtual and erect. Okay. So this is a case of two cases that we have discussed for convex mirrors. Let us take an example. Complete the ray diagram shown in figure to show the formation of image for parallel rays incident on a concave mirror. State position, nature and size of the image formed. So this case we have discussed case 2 in which a faraway object is considered. Okay, so this is a first incident ray. Let us say A, B, and this is C, D. Okay, so here we have the normal. Okay, so here we have the normal. This is the first ray. For this, we are considering this as a normal. What is normal? A line that is passing through the center of curvature and the point of incidence. So here we have normal, here we have angle of incidence. So same angle you will get. Okay, you can draw the reflected ray. Same angle you can draw the reflected ray. Okay, similarly here we can draw a normal, point of incidence is considered and the center of curvature is considered. Draw a line that is passing through the center of curvature and the point of incidence. So you will be getting the incident angle. Now you can draw the reflected ray. Okay, you can draw the reflected ray. Same angle should be measured. Okay, draw the reflected ray. Okay, so here this is a point of intersection. From this point of intersection, draw a line that is perpendicular to principal axis. Okay, so this is a concave mirror. Okay, so this is how the image will look like. So this is a completed image. Okay, now what are the properties? State position. Where is the image formed? Image is formed. Image is formed at focus in front of mirror. Okay, nature of image. Nature of image. The image formed is a real image. It is obtained, can be obtained on a screen. Real image. Okay, next, real images are always inverted. Inverted image. Third one, we have to find the size of the image formed. What has happened to the size? Okay, we are considering a far away object. The size of the image will be smaller than the size of the object. It will be highly diminished. Highly diminished, or in simple words, a diminished image is formed. So these are the properties of the image formed. Second example, complete the ray diagram shown in figure to show the formation of image for parallel rays incident on a convex mirror. State position, nature and size of the image formed. So here we have the light rays. This is a pole. AP is the first light ray. It makes an angle. Okay, a line that is passing through the point of incidence and center of curvature is a normal. So here in this case, this is a normal. Okay, angle is made. Same angle will be made. You can draw the reflected ray. Okay, now second case. This is the next light ray. Let's say B, D. D is the point of incidence. Point of incidence and center of curvatures are considered. And a line is drawn. A straight line is drawn. Okay. So here, this is the straight line that is drawn. And this line will be the normal. Okay. What happened to the reflected ray? It will pass along the same. It will follow the same path. Now, you are extending the reflected ray in the first case. Okay. So, here you will get the image. Okay. At the focus, you are getting the image. This is a case of a convex mirror. So, where do we get the image? Image is formed at focus. Okay. Next, the properties of the image. Nature of image. Position we have got, nature of image. The image formed is a virtual image. It is an erect image. Okay. It is an erect image. What else? Size. What has happened to size? In case of convex mirror, always will be getting only diminished images. Okay. So, we'll consider these light rays are from infinity. In that case, you will get highly diminished image. Highly diminished image. Understood? That's all for today. In today's class, we have discussed about the two types of spherical mirrors. We have studied how to draw ray diagrams in case of a concave mirror and convex mirror. We have considered different cases for each. Hope you all enjoyed the session. I'll be back in the next session. Until then, stay tuned to Learnohub. Learnohub free hai, par best hai. Thank you.